right, we're going to find the molar concentration for this first question. We have 7 grams of potassium permanganate, KMnO4. That's supposed to be a little n, into 30 milliliters of water. And we're going to find the molar concentration of this substance. Okay, so first thing we're going to need to do is find our molar mass. Pretty much always going to need to find our molar mass if we're converting between grams and moles. So potassium, here we go. We have a mass of 39.10 grams per mole. And then we're going to look up permanganate. And I'm just going to point out the permanganate ion here is MnO4. Okay, so Mn, manganese. We're going to find our manganese here. And you can see it's 54.94. So this is supposed to be Mn. 54.94 grams per mole. And then oxygen. And we have 4 of them, so we can't forget about that. So we're going to have 4 times our mass of oxygen is 16.00 grams per mole. So we're going to add these all up. And I will first put in my oxygen, 16 times 4, enter, plus 54.94, plus 39.10. So our molar mass for permanganate is 158.04 grams per mole. All right. Now we're going to use our little triangle to figure out our formula that we're going to use. So we have our mass, our moles, and our molar mass. Okay, so we've got our molar mass. We've got our mass. What we need to find is the moles. So if I cover N, that's our moles, and we are going to use our formula of mass divided by molar mass. So to find the moles, we're going to go N equals mass divided by molar mass. So our mass is 7 grams. Our molar mass we just calculated, 158.04 grams per mole. Let's pop this in the calculator. 7 divided by 158.04 should be a small number. Yes, it is. 0.044292. I won't round off quite yet. And this is moles. We just found N, which is moles. All right, so we know our moles, and now we need to turn this to concentration. So remember that concentration is moles per liter. So concentration, if we want to do a little triangle for it too, is the number of moles per liter, or volume. So there's our little triangle for finding concentration, or finding volume, or finding the moles if we have concentration. But anyway, so if we want to find the concentration, molar concentration is number of moles over our volume. Remember, our volume has to be in liters, so that's a bit of a problem right now. We have milliliters, so let's just change that to liters. So I'm just going to take that over here. So 30.0 milliliters, and there's 1,000 milliliters in a liter. So we're going to multiply. To get rid of our milliliters, we're going to have milliliters on the bottom, and there's 1,000 milliliters in 1 liter. I like using conversion factors. I find they help me out. I get rid of my milliliters, and I end up going 30 times 1 divided by 1,000. So let's just do that here. 30 divided by 1,000, 0.03 liters. Or if you get pretty comfortable at this, you could say 30 milliliters. I just have to divide by 1,000 to get to liters and just move the decimal over 3 places. All right, so there's our volume. 0.03 liters is our volume. Our moles, we calculated up here. 0.044292 moles. So let's Let's see what we get. 0.04422925 divided by 0.03. 1.476416. I'll round now. And now I'm going to go back to my original question. There's 3 digits here, 3 significant digits here. So I'm only going to have 3 significant digits here, but my 7 is going to get rounded up. So 1.48. And my units, I'm dealing with concentration, which is moles per liter. There is my answer. So there's quite a few steps when you're given a question that has mass of a substance and volume, especially if it's not in liters. Another extra step. So we got to go from mass to moles, and then get our concentration into liters, and then take our moles and divide it by our volume.